Question 23. Simplify the following. 5a squared minus 4a times a minus 3. Okay, first simplify and then look at the choices that they give you. 5a squared, we leave alone here. We do this multiplication first. Minus 4a has to be distributed through the parentheses. Minus 4a times a is minus 4a squared. Minus 4a times minus 3, minus times a minus is plus 12a. So we have, combining the like terms, 5a squared minus 4a squared gives us 5 minus 4, 1a squared, or a squared, plus a 12a. A squared plus 12a, which is choice D on the test. Question 24. Add 3x squared minus 2x plus 4 and x squared minus 5. Now they have it written along horizontally. We want to add x squared minus 5. So I'm going to do it vertically and I'm going to line it up, the x squared minus 5 in that fashion. And it said to add 3x squared minus 2x plus 4 and add to that x squared minus 5. And line it up so that the like terms appear under each other. 3x squared plus 1x squared is 4x squared. Minus 2x and 0 is minus 2x. 4 minus 5 is minus 1. So 4x squared minus 2x minus 1. And be careful because there are 4x squared minus 2x plus 1 and plus 2x minus 1 are all choices. 4x squared minus 2x minus 1 is choice A on the test. It would be silly to get it to this point and then to copy down the wrong answer. Question 25. 5 x cubed y to the 4th quantity squared. Okay, this means that the 5 is squared, the x cubed is squared, and the y to the 4th is squared. The 5 squared, of course, is 25. X cubed squared, you multiply the 3 times the 2 and get 6. X to the 6th, y to the 4th squared, 4 times 2 is 8. And the answer is 25, x to the 6th, y to the 8th, which is answer A. The most common mistake, of course, in a problem like this would be adding the exponents. Remember, if it's x cubed times x squared, that is x to the 5th. In other words, you're multiplying x cubed times x squared. This is really x, x, x. This is x, x. So there's a total of 5 of them, x to the 5th. However, we have here x cubed squared. This means x cubed times x cubed. And of course, in this case, there are 6 of them. So you get x to the 6th. So please look at the difference. When you have the same base, you multiply, you keep the base, and you add the powers. But this is just a straight power. You multiply the 2 exponents. Question 26. Simplify 12a squared plus 16a over minus 4a. Okay. On the videotapes I showed you actually 2 ways of doing this. One way of handling it is to simply say when you have a group of terms in the numerator, you can break it up, put each term in the numerator over the same denominator. So 12a squared over minus 4a plus 16a over minus 4a. And in this case, 12 divided by minus 4 is, of course, minus 3. A squared over a is a. 16 divided by minus 4 is minus 4, and the a's cancel. So minus 3a minus 4 is the answer to this problem, and that is choice D. Question 27. Factor 9x cubed minus 15x squared. All they're looking for is you to pull out the greatest common factor here. Between the 9 and the 15, the largest number that goes into both of them is a 3. Between the x cubed and the x squared, the most you can pull out is the x squared. And then to collect the terms and see what you're left with. 3x squared times what would give you the 9x cubed? Well, to go from 3 to 9, you'd need it multiplied by a 3. To go from x squared to x cubed, you'd have to multiply by an x. To go from 3 to minus, well, I have the minus here, so to go from 3 to 15, you need to multiply by 5, and you already have the x squared. To check this, you would immediately now use the distributive law. 3x squared times 3x is 9x cubed, minus 3x squared times 5 is minus 15x squared. So it checks out. This is answer E, 3x squared times 3x minus 5. By the way, if you're very bad at factoring, one thing you might do, if you prefer to multiply out, would be to use the distributive law on each of the answers that they give you on the test until you find one that multiplies out to 9x cubed minus 15x squared. Okay, but that takes a lot longer. Question 28. 2 times minus 5 squared plus 4 times minus 7. Okay. First thing, we're using now order of operations. First thing that we'll do is the power. Minus 5 squared is minus 5 times minus 5 is plus 25. So it's 2 times plus 25 plus 4 times minus 7. Now let's do the multiplications. 2 times plus 25 is plus 50. 4 times minus 7 is minus 28. 50 minus 28. And the answer is 22. And that is answer B. Question 29. Find x if 4x plus 3 equals 5x minus 1. They're asking you to solve this equation for x. Okay, we'd like to get x alone on one side, everything else on the other side. We'll subtract 4x from both sides. And that gives us 4x minus 4x. That drops out. 3 equals 5x minus 4x is x, now minus 1. And then add 1 to both sides, giving us that x equals 4 is the answer. It, by the way, is answer D. Of course, you can check this one. This should work when you plug in x equals 4. 4 times 4 is 16 plus 3 is 19. 4 times 5, 20 minus 1 is also 19. In fact, if you did not want to solve this equation, what you could do is to try each of the possible answers that they gave you and to see if it works, which one checks out in the equation. Okay, let's do one more problem, and then what I'm going to do is to finish the rest of this exam on another videotape. Okay, I don't want you to have to sit too long at one time, and I'm not sure I can make it in an hour. So I'm going to do one more problem, and then the remaining problems up to question 40 will be on the next videotape. So when you finish this tape, ask the tutor for the second part of this tape. Okay, the last question on this tape is the following. Find the value in dollars of T $10 bills and F $5 bills. Well, one $10 bill is worth $10. Two $10 bills, 2 times 10 is worth $20. T $10 bills would be T times 10 or 10 times T dollars. One $5 bill is worth $5, two $5 bills, 2 times 5, $10, three $5 bills, 3 times 5, $15, and F $5 bills, 5 times F dollars. So the answer is 10T plus 5F, and I look on the paper and I see that that's not one of the choices, but 5F plus 10T is, and that is in fact choice C. Starting with question now 31, if x equals 4 and y equals minus 3, find the value of x squared minus 5xy. Okay, x is 4, so that's 4 squared minus 5xy. X is 4 and y is minus 3. 4 squared minus 5 times 4 times minus 3. Well, 4 squared is 16. Now, minus 5 times 4 is minus 20. Minus 20 times minus 3 is plus 60. So we have 16 plus 60. The 4 squared is the 16. Minus 5 times 4, as I said, is minus 20 times the minus 3 is plus 60. 16 and 60 is 76. And 76 is choice A on the test. So the answer to question 31 is answer A. Question 32. Okay, if x over 5 equals minus 3 over 4, find x. Okay, an easy way to solve this fractional equation, since we have only one fraction equal to another fraction, is to cross multiply. X times 4, or 4x, equals minus 3 times 5, or minus 15. And then to solve for x, we divide both sides by 4. X is therefore minus 15 quarters, and minus 15 quarters is choice C on the test. Question 33. Which of these points lies on the graph of 4x minus y equals 9? And they give you 5 different points. Okay, what you have to do is to check each point. If the point lies on the graph, when you substitute the x and the y values given for the coordinates of the point, you will get a true statement. In choice A, they give you the point 2, 1. This means x is equal to 2 and y is equal to 1. Let's see if we get a true statement. Well, if x is 2, this becomes 4 times 2 minus y, which is 1, should be equal to 9. But that gives us 8 minus 1, and of course 8 minus 1 is 7. 7 is not equal to 9, so choice A is out. And we move now to choice B. Choice B is the point 2 minus 1. X is 2, y is minus 1. So 4x minus y equals 9. 4 times 2 minus y, which is a minus 1, should be equal to 9. Well, 4 times 2 is 8. Minus a minus 1 is plus 1. And of course, this does work out. 9 equals 9. So we don't have to go any further. The correct choice is choice B. Choices C, D, and E will not work out either. Okay, so 2 minus 1 is a point on this line because when you let x be 2 and y be minus 1, you plug into this equation, you get a true statement. But remember, the first one should be the x value, the second one should be the y value. Question 34. They ask you to find an equation for a line, and they draw a picture of a line. And the line that they give you looks like this. It has a y-intercept of 2 and an x-intercept of minus 1. So they show it to you like this. And they ask for an equation of that line. They give you 2 points on the line. There's very often a question like this on the assessment test. They draw the line, and what they're really giving you is 2 points on the line. If they tell you the y-intercept is 2, this is really means that the point 0, 2 is on the graph. Okay, that's the point 0, 2, x equals 0, y equals 2. If they're telling you the x-intercept is -1, that means the line goes through the point -1, 0. So we know 2 points on the line, -1, 0, and 0, 2. If we want to get the equation of a line and we know 2 points on the line, the first thing we do is figure out the slope of the line. And after we have the slope is y2 minus y1 over x2 minus x1. We will then substitute into the equation y minus y1 is m times x minus x1 to get the equation of the line. Okay, now either point could be called x1, y1, and the other one is x2, y2. It doesn't matter. Let's say we call this x1, y1, and this x2, y2. Okay, it doesn't matter which is which as long as you're consistent. We want y2 minus y1, 0 minus 2 over x2 minus x1 over -1 minus 0. That gives us -2 over -1 or +2 for the slope. Okay, and it doesn't matter now which point you use in the point-slope form of the equation of the line, but since we've called this x1, y1, we can be consistent and use that. Y minus y1, y minus 2, is the slope, which we just found to be 2, times x minus x1, which is 0. So we get y minus 2 is 2 times x minus 0, or y minus 2 is 2x minus 2 times 0. Or, well, we can write this as y minus 2 is 2x, or y equals 2x plus 2. And now let's look at the various answers that we get on the test. Y equals 2x plus 2 is not one of the choices. However, y minus 2x equals 2 is one of the choices, and of course that's equivalent to this one. If we were to subtract 2x from both sides of the equation, we get y minus 2x equals 2, and that is one of the choices on the test, and that is choice D. Okay, so first go about your business. They give you the x and the y intercepts, write them as points. You have 2 points, get the slope of the line through those 2 points, and then use the point-slope form of the equation of the line, all right, to get the equation of the line, and then try to have it match up to one of the possibilities on the exam. And as I said, they could have, for the same effort, have written the answer as y equals 2x plus 2, but they chose to write it as y minus 2x equals 2. All right, question 35 on the exam. C is equal to 8ab squared, and they ask you to find C if A is -1 and B is 2. Find the value of C. A is -1 and B is 2. So C is 8 times AB squared. A is -1 and B is 2. Okay. 8 times -1 times 2 squared. Squaring the 2, we get a 4. And now 8 times -1 is -8 times +4 gives us -32 as an answer, and that is choice C. Question 36. If 4p minus q equals 5, then they want you to solve this formula for p. Okay? To solve for p, got to get p alone on one side of the equation. So to get p alone, I will add q to both sides. 4p is 5 plus q, or q plus 5, however you want to write it. And then if I want to get p alone, 4 times p is here. I divide both sides by 4. And p comes out, 4's cancel. P is equal to q plus 5 over 4. And that is choice C on the test. Question 37. A batter gets 2 hits for every 7 times at bat. How many times must he come to bat in order to have 150 hits? He gets 2 hits for 7 at-bats. How many times must he come to bat in order to have 150 hits? Okay, he'll get 150 hits in X at-bats. So we're setting up a proportion. 2 hits is to 7 at-bats, as 150 hits is to X at-bats. How many times does he have to come up at bat to get 150 hits? Okay, that is 2 is to 7, as 150 is to X. And once again, we have a fractional equation where just one fraction equal to another, and that can be solved by cross-multiplying. So 2x is 7 times 150, or 2x is 0. 7 5s are 35, 3 and 7, 10. 2x is 1,050. Divide both sides by 2. X is 525. So he needs 525 at-bats in order to get 150 hits, assuming that it works in this proportion. So 525 at-bats. And that is choice D. 37, the answer is D, 525. Question 38. Okay, you're given a right triangle. You're told that this leg has length 1, this leg has length 4, and the hypotenuse has length x, and you're asked to find x. Okay, in a right triangle, of course, a squared plus b squared is equal to c squared. That is, the square of the hypotenuse is equal to sum of the squares of the 2 legs. Well, in this case, a is, say, 1, b is 4, and the c is the x. So 1 squared plus 4 squared is equal to x squared. 1 plus 16 equals x squared. 17 equals x squared. To get x, we'll take the square root. It's plus or minus, but since it's the length of a side, it must be plus. It's plus the square root of 17. And that is one of the choices. Okay, don't do it quickly. I mean, they list 17 as one of the choices, expecting you to fall into the trap of forgetting to take the square root. Okay, the answer here is the square root of 17, and that is choice D on the test. Okay, question 39 asks us to solve 2 equations and 2 unknowns. They tell us that 3x plus 2y equals 7, and 3x minus y equals 1. And then they ask you to solve to find out what x and y are. Okay. The easiest way to handle this would be to use elimination. That is, we'd like to eliminate one of the variables. If we leave the first equation alone, 3x plus 2y equals 7, but we multiply the second equation through by minus 1. Minus 1 times 3x would be minus 3x. Minus 1 times minus y would be plus y. Minus 1 times 1 would be minus 1. We multiply the second equation through by minus 1 and then add the equations. We are able to eliminate the x's because 3x and minus 3x drop out. 2y plus y is equal to 3y. 7 and a minus 1 is equal to 6. Dividing by 3 gives us that y equals 2. Once we know what y is, we can substitute into any of the equations. Let's say we substitute back into the original equation 3x plus 2y equals 7. We know y is equal to 2. 3x plus 2 times 2 equals 7. 3x plus 4 equals 7. Subtracting 4 from both sides. 3x equals 3, because the 4's cancel. Dividing by 3, x equals 1. So we have that x equals 1 and y equals 2. And we can check this by substituting back into the equations. X is 1 and y is 2. X is 1 and y is 2. We would get 4 plus 3 is 7. And here, 3 minus 2 equals 1. So it does check. This combination, x equals 1 and y equals 2, is choice B. Since they do give you all of the possible choices, if you do not want to solve the equation, or if you have trouble solving the two equations and two unknowns, what you might do is to go through each pair of choices that they give you and see if they satisfy. The first choice, they say x is 1 and y is 1. And it's very easy to see x equals 1 and y equals 1 cannot satisfy that equation. And this, in fact, is the second choice. So that is an option to you as well, to actually check all of their various answers in the equations. The last problem on the assessment test, the sample assessment test that we're working out, is question 40. It says, it costs a toy manufacturer $5 to produce a hockey game. In addition, there is a general overhead cost of $15,000. He decides to produce 6,000 games. If he receives $15 per game from a wholesaler, how many games must he sell to break even? Okay, we want to find out how many games he must sell. So let x equal the number of games he must sell. As in earlier problems, we have that the profit will be equal to the total sales minus the costs. Now, he is selling the games at $15 per game. We're not sure how many games he must sell. Let's say he sells X games. Okay, the total sales will be 15 times X dollars. $15 per game, and he's selling X games. Now, the costs. We are told that there are basically two costs. There's a general overhead cost of $15,000. And there is also a per game cost. It costs $5 to produce the hockey game, and he makes 6,000 games. So it's 6,000 games, $5 per game. That's $30,000. That's an additional cost. We have the general overhead cost of the $15,000, plus he makes 6,000 games at $5 per game, so an additional $30,000 to be subtracted. Okay, the profit will be the total sales. If he sells them at $15 a game, and there are X games. He doesn't necessarily sell all of the games. Okay, he's selling X of the games, but he did make 6,000 games at $5 a game. That cost him $30,000, and $15,000 overhead. Now the question is, how many games must he sell to break even? To break even means the profit will be 0. At that point, he breaks even, and anything, in other words, if he sells less than X games, if we determine what X is, he will be losing money. And anything more than X, he will be making money. This is the point at which the profit will be 0. So 0 is equal to 15X minus 15,000 minus 30,000, so minus 45,000. or adding 45,000 to both sides, 15x is equal to 45,000. Dividing both sides by 15, x is equal to 15 goes into 45 3 times, so we'd have 3,000. So he must sell 3,000 games to break even, and that's choice B on the test. Let's check this out. If he sells 3,000 games at $15 a game, he will bring in $45,000. Okay, less his fixed costs of 15,000 overhead and 30,000 to produce the 6,000 games. Of course, he has now an additional 3,000 games, and if he can sell those, he will be making profit. That brings us to the end of this tape.